So in simplification of context-free grammar, the first part was useless symbols. The second part is elimination of epsilon production. So we'll see the second, that is elimination of epsilon productions. So a production of form A belongs to epsilon, that is you can replace A with epsilon, is called a null production or an epsilon production. So when we say that A can be replaced with epsilon, we say that such kind of production is a null production or an epsilon production. For every context-free grammar G with epsilon productions, we can find a context-free grammar G1 having no epsilon production, such that, how will you do that? That context-free grammar G1 having no epsilon productions will be found out as L of G. That means the original grammar with epsilon productions minus the epsilon productions, you get the new context-free grammar G1 having no epsilon productions. So G was the grammar with epsilon productions. You subtract the epsilon productions, you get a new context-free grammar G1 having no epsilon productions. The procedure for finding G1, that is equivalent grammar without epsilon productions, removing the epsilon productions, removing the null productions, is as follows. Step number 1, find nullable variables. Step number 2, addition of productions with nullable variables removed. Step number 3, remove epsilon productions. Step number 1, find nullable variables. A symbol X is nullable if. So when can you say that X is nullable? That is, X is an epsilon production, epsilon symbol. Whenever there is a production of the form X is belong to your epsilon, that means you can replace X with epsilon, then you say that X is nullable. And if there is a production of the form X belongs to alpha and all symbols of alpha are nullable, then you say that X is nullable. For example, let's see an example to get a clear picture. You have been given these productions. So in this, what you see, A can be replaced with epsilon, B can be replaced with epsilon. Therefore, we say that A and B are nullable. Because A and B are nullable, even S is nullable. Why? Because S has ABA, that means S can be also replaced with epsilon, because A can be replaced with epsilon and B can be replaced with epsilon. So we say S is also nullable. So what have they given you? A is nullable as there is a production A belongs to epsilon. B is nullable as there is a production B belongs to epsilon. S is nullable as there is a production S A B A. So with both A and B as nullable, therefore the set of nullable symbols are S A B. So we saw B is nullable, A is nullable, therefore S is also nullable. Step number 2, addition of productions with nullable variables removed and epsilon production has an effect. This effect must be added as productions to the existing grammar before epsilon productions are removed. So let's see an example to get a clear picture. Remove epsilon productions from the given grammar. You have been given a grammar and you have been told to remove the epsilon productions to eliminate the epsilon productions. So find the nullable variables. First, to find the nullable variables, we see that A is replaced. A can be replaced with epsilon. Here you have epsilon. B can be replaced with epsilon. Because A and B can be replaced with epsilon, even S can be replaced with epsilon. So conclusion is A, B, S are nullable variables. Nullable variables. So we conclude that A, B, S are nullable variables. Now addition of productions with nullable variables removed. So this is your step number 2. How is your step number 2? When you find that A, B, S are nullable, what will you do? S you have A, B, A. Your S is what? A, B, A as given in the question. So we will split now this part. So how will you split? S will be A, B, S will be B, A. S can be A, S can be single A, S can be replaced with a single B, or S can be replaced with epsilon. A is small a and capital A. So we saw here small a and capital A in the question. So small a and capital A, again you had a epsilon, so you have to create more than one productions. So we'll say this can be replaced with small a. B is small b and capital B can be replaced as B was initially this. You can also have one more production because this was with the epsilon. We have one more production, that is small b. Now equivalent set of productions will be S can be A, B, A replaced with A, B, A can be replaced with A, B can be replaced with B, A, single B, or a epsilon. This capital A can be replaced with A, single A, or epsilon. Capital B can be replaced with B, single small b, and epsilon. Now the next step is step number 3. Remove epsilon production. So when you remove epsilon productions, you remove this, and you remove this. So when you remove, you get the final answer, or by that is eliminating the epsilon productions. Let's see one more example. Remove epsilon productions for the given grammar. So here first find out which of them are nullable. So you say A is belonging to epsilon. So A is nullable. B belongs to epsilon. B belongs to epsilon. So B is also nullable. And S is AB, because A is also nullable and B is also nullable. So S is also nullable. So what did we find out? We found out that A, B, S are nullable. After that, what we do? We split. How do you split it? S is AB is one production, S is A, single A, another production, S can be replaced by single B, another production, S can be replaced by an epsilon. So this is your production: AB, single B, and epsilon. For S, for A, single A, for A you have A, and small a. So these are the productions for A. For B you have the one which is given in your question is small b, BB, then small b and capital B, and small BE. So removing the epsilon productions. Step number 3. What we get? For S you had AB, A and B. So for S we had AB replaced with AB, replaced with A, or replaced with B. For A we had replaced it with small a, capital A, and one more capital A, or replace it with small a, capital A, or replace it with small a. For B we had B, small b, capital B, small b, capital B, and small b. So these were all the possible productions. So this is what? This is after eliminating the epsilon production. This is your final answer.